So, good morning, everyone. It is my pleasure to welcome you to the webinar on energy efficient and digitalized building stock, also known as DHC-ready buildings. My name is Junasova. I'm a project officer at Euroheat and Power, and I will be moderating this webinar, which is organized as a Sustainable Energy Day event. The energy used for heating and cooling in buildings and industry accounts for 50% of the EU's annual energy consumption. However, the installation of smart control systems allows users to regulate their energy consumption and benefit from lowest energy prices. So today we will look at how digital solutions can improve the energy performance of buildings and prepare them for new generation of district heating systems. We will also look at the current policy aspects related to efficient buildings and some innovative approaches and solutions being developed in EU-funded projects. So I would like to begin by welcoming our expert speakers and giving you a brief overview of today's agenda. First, we will hear a keynote speech from Anna Marszal-Pomianowska, who will introduce the topic of energy efficiency in buildings and district heating and cooling, and explain the importance of buildings' readiness for integration into DHC networks. We will then hear presentations from 3 EU-funded projects that are contributing to energy efficiency through the development of digital tools. The DigiBUILD project will be presented today by José Hernández García. Then Sofia Mulero will present the Build-On project. And finally, Stamati Arizu will share insights from the SRI and ACT project. And last but not least, the policy aspects will be covered by Remi Colombet, who will explain the definition of efficient buildings in the Fit for 55 package. So welcome to all of you, and thank you very much for being here. And after all these interesting presentations, we will have some time left for a panel discussion. Therefore, I invite you and encourage you to use the Q&A section to write down your questions. You can do this anytime during the webinar, even while the speakers will be presenting, so that you won't forget about your question. And we will come back to all these questions at the end of the webinar. I would also like to kindly ask you to tag a speaker you wish to address your question to help us to facilitate the discussion afterwards. All right, just one more remark on the organizational aspect. Please know that the webinar is being recorded and will be published later on the Euroheat and Power YouTube channel. So I think that's everything from my side for the introduction, and I'm pleased to hand over to our first speaker, Anna Marszal-Pomianowska. She is an associate professor at the Department of the Built Environment at Aalborg University. And for the last 10 years, her work has focused on the social and technological aspects of the interaction between the build sector and the energy system, and how buildings and end users can contribute to the green transition. So Anna, the floor is yours. What do you think? Is the EU building stock energy efficient and digitalized at the moment?
That's a tough question, but first I would like to welcome everyone and thank you for the invitation to give this brief introduction if actually we have efficient and digitalized building stock. I think that we would like to have it, but the reality is unfortunately far away from what our aims and what politicians are setting the goals. So there is still a lot of work and improvements we can do to our building stock. And saying this, I would like to move to my slides and the presentation. So yes, I will try to briefly tell about the energy efficient and digitalized building stock that is suitable for renewable district heating and cooling systems, because we are in the district DHC plus framework, so everything has to be related to those thermal grids. And I would like to start with the motivation maybe to our work that is set by the European Union. And many of you know, and we will hear also at the last presentation about the Fit to 55 framework that was accepted or approved by the European Commission. And in the center of the slide, you can see kind of what are the different packages related to fulfill the emissions in 55% in 2030. But I will not touch upon all of them, but I will focus the ones that relate to the building sector and also district heating and cooling networks. So on the left-hand side, you can see the directive called EPBD, that is Energy Performance of Buildings, and this is the directive that sets the goals on the European level that later on should be adopted by all the member states. And if you see actually here, there are different steps that is focused on the new construction, that actually already in 2030, it should be all new public buildings should be net zero energy buildings. And in 2030, it should be actually all new buildings. The existing buildings, they have their own kind of set of goals because they are more challenging than the new builds. That's why you can see kind of like how the reduction of greenhouse gas emissions should be happening and what are the steps reduction in those. And then you also have a new set of or some regulations for the residential buildings that they should reduce their greenhouse gas emissions by 10% to what I can see, and 20 to 25% in 2035. So it is kind of like divided and acknowledged that we have different challenges for the new builds that are more ambitious regulations, and the existing buildings should slowly also catch up with the new build. So this is regulations related to the buildings. And then on the right-hand side, you have the Energy Efficiency Directive and then Renewable Energy Directive that is pushing our district heating and cooling systems, how they should implement stepwise more renewables in their system, and then thereby reduce the greenhouse gas emissions. And I will not go through all those steps, but you could see actually that the goal is actually to be 100% renewable in 2050 with those stepwise reductions on the way. So you could see that we have two or actually three directives that is pointing both to the building sector, that is actually the core of the district heating and cooling, because one cannot exist without the other. And on the other hand, you also have the district heating and cooling system's own transition. So I would like you to look on the red line, that is actually the temperature of the supply water. And you could see that in the first generation systems, we started with the steam that was actually above or somewhere around 200 Celsius degrees. And with the progress from first to second and third, and now actually a lot of systems are aiming toward the fourth generation, the supply temperature is actually only around this 60 degrees. So you can see a significant drop. And this also pushes the energy sector or the building sector to be designed and to be operated that actually those temperatures are enough to heat our houses. This is also pushed because of, you can see actually how many different systems or different technologies are involved in the different district heating generations. And we expect to have more lows, waste heat, more heat pumps that actually operate best on the low temperatures. So this is also what is pushing the building stock to actually become more efficient and enable this transition for the district heating and cooling systems. So those are the, let's say, the drivers for building stock to go through this energy efficiency and digitalized also transition. But then you can actually, this is related to my previous answer, the question of, is our building stock actually energy efficient and digitalized? And when you look on the left-hand side on the slide, actually this is the recent statistics from European Union. You can see 75% of the existing buildings are inefficient. So actually we have only a little bit, 1/4 of building stock that is actually suitable to operate on these low temperatures that the district heating systems will provide to their customers. Then the next question is the building stock digitalized? And this is kind of like a little bit difficult to say, how do you measure if the building stock is digitalized ready? But I came across some statistics that is kind of like showing how high is the penetration of smart homes that to some extent often understood as buildings that are digitalized, having some smart solutions that we can control remotely, set our thermostats to be on and off. And actually you can see that in 2025, so kind of next year, we aim to be on around 19% of penetration of smart home in the building stock. They hope that actually in only 3 years, this will more than double, but this is the prognosis. Yes, so we will see actually if this will be possible, that we will have this control and connectivity components of the smart homes installed in those houses. So you can see the line is steep, and let's hope that this will be the reality. Then actually on the bottom, you can see something that is happening right now, and this is also pushed from the European Union. This is the directive actually setting that all houses that are connected to, or all buildings connected to the district heating networks, they should have a so-called smart meter. So the meter that can be remotely read, and at the same time, it's actually registering the consumption every hour. And if we think that actually this consumption will be registered every hour, this is a huge step, a huge improvement, because until now, a lot of houses, they had their consumption read monthly. This was actually quite nice, but sometimes even once or twice a year. But with this readings every hour, we can actually say that this is maybe a very first but big step towards digitalization of the building stock, because this is a smart meter on the heat side. There is, of course, a smart meter on the electricity side. And also they are starting, and the rollout happens on the smart meters on the water side. So if you imagine that you have all those meters ready and delivering data every hour, we think that this will be a really nice source of information of what happens in the building. And this will be a very big step towards digitalization. Yes, and now I will kind of starting with this framework, say to you what we do on our side in Denmark with this data from smart heat meters. So our utilities, the Danish building district heating sector is actually very well developed. More than 65% of our buildings are connected to the system, to the district heating system. This means that we have a lot of data from around 2022. We have already started to collect this hourly heat consumption of the buildings. And actually we have collected this data, and we were able to actually cluster more than 4,000 buildings and see how the consumption changes between those buildings. So this is what you can see on the y-axis, but also in time. This is the x-axis. And this is actually very nice to present that in this given context, in this given network, they have 6 clusters of different customers, of different groups, and then they have 6 different periods. So you could think about, we are used to say we have summer, winter, fall, and spring. But actually our studies are showing we have 6, and we don't have fixed heating start point of the heating season. So this already allows us to understand, and the utilities to understand how maybe they should operate. Where are the buildings that consume a lot during the winter time? Where are the buildings that consume little during the, for example, winter time? So then they can optimize, they can maybe think, okay, this is a building that we can maybe start to renovate. We have also tried to correlate those clusters with information on the building characteristics and actually socioeconomic analysis of the occupants of the houses. And I think this is not something new, what I would say, but this is kind of like proven with the numbers, and we like numbers, is to hear that actually we can only explain around 50% of those clusters. So meaning that if we have a pool of 100 houses, we are able only to put only 50 houses in those clusters, and the remaining 50, we don't know where they belong. And this is because there is all the heating habits that occupants do. There is their heating practices that actually impact how the load looks like. And we don't have this information. So this is kind of where we feel like that there is still a kind of a low-hanging fruit, maybe to look into more occupants to achieve this energy efficient buildings. This is actually a better example to what I'm saying to you. This is an analysis we have conducted 4 identical apartments located in the same multifamily building, the same weather conditions, the same windows area, the same properties of the windows, and still you could see this is the so-called energy signature. So you have here outdoor temperature in relation to how much heat they use. And you can see actually those are different curves, meaning that people use heat differently. Here you can even see the same apartment occupied by 2 different families. One, you could say, okay, they actually use less energy, the line is more flat, and the other ones you could see they use more. So probably either they have higher temperatures, maybe they ventilate house differently, maybe they don't use all radiators to heat up the houses, to heat up the apartment. Maybe they have only one. That means that actually it's, we call it inefficient behavior to heating behavior. So kind of this very simple correlation between the outdoor temperature and space heating demand is showing us how big impact actually the occupants' heating habits have on how and when the heat is consumed. Yes, and then to build further on, to kind of like zoom even more on what happens in those apartments and where are potential faults or places for efficiency improvements. Yes, so where are those inefficiencies? We also work with this data, and I have to say it loud and clear, this is the data that comes from the commercial smart heat meters. We don't do any magic, I call it, to the data. We don't treat it to actually be, I don't know, higher resolution or kind of like, looking better. We just take what all the utilities have from the smart meters, and we looked into faults. Yes, and the first thing that we have actually acknowledged is that many occupants, they don't understand how to operate efficiently their heating systems. They think that if they have one radiator running, this is actually most efficient way to heat up their houses. We also acknowledge from this that the heating systems are very diverse, and this is the challenge to kind of like make a uniform energy efficiency I don't know, policies or standards, because some people have underfloor heating in the whole apartment, some people have only in the bathroom, some people have it only in the in the basement or in the garage. So all of those actually operate differently, and this is what we have looked into, kind of like what are the typical behavior of the data we get from the smart meters to actually indicate us what is the fault. So here we have 4 different faults. You can see this is kind of like slow degradation of the component. This is the top left one. Then you have a kind of like a sudden impact, a sudden increase of the flow, and then it stays constant. Then we call it kind of like a stroke, when there is peak, but then actually it's not visible here, but it goes back to the same performance and then kind of goes back to peak and then below. And then we actually looked into, we were so lucky to get some reports from the utilities indicating us what the people trying to fix those have registered. So you could see actually a lot of the faults are the radiators, and this is both the indication of the energy and then indication of the volume flow and the return temperature. Our main finding was actually that if we want to proceed in this automatic fault detection, and this is what many utilities would like to do, we have to move away from energy and then actually start to look only on the return temperature from the houses. Or, of course, sometimes in combination with the volume, those 2 parameters should help us to achieve energy efficient building stock that is actually using the digital data available to help the energy efficiencies. And then I think the final slide is actually, again, going back more to the helicopter perspective. What I like to say is to look what is the potential, where are the weaknesses, where are the opportunities, where we want to integrate more the energy system, the heating and the heating sector with the building sector. So how they two can benefit each other, building, delivering some flexibility, maybe some storage, the short-term storage to the thermal networks. And we have conducted the SWOT analysis, identified 17 different components. One of them, for example, is that there is a lot of state-of-the-art knowledge on this aspect. Let's say district heating and cooling professionals, they just have to tap on this state-of-the-art knowledge and then hopefully integrate it in their business as usual practices. We have acknowledged that customers, they are ready and they are aware about their potential to contribute to solving some challenges in the district heating and cooling sector. It's a lot about social and economic aspects we have to think about. So what are the business models to activate the buildings, how digitalization can help to do it. Maybe actually one of the weak points of the kind of proceeding with even better digitalization is lack of sharing the data between the different stakeholders in all the value chain that is created there. And I think I could look on the time. I have used my time. So this is kind of a finishing slide to tell you that if we want to reach this efficient and digitalized building stock, we always have to think about the building systems. So not only about the household practices and actually about the surrounding utilities and framework that we have, because some energy efficient and digitalized building will be suitable for one type of the district heating system, but the same ones might not fit to another configuration of the district heating and cooling system. So we always have to think copy-paste solutions are maybe good to look at, but not the only way to go. So this was all from my side. And thank you very much for the invitation and possibility to talk about this, the building stock.
Thank you very much, Anna. Thank you for your opening presentation. And indeed, we should start thinking holistically about energy efficiency in buildings, as it should address the buildings and its occupants to be successful. So once again, thank you. Let's move on to the next presentations of 3 EU-funded projects that are developing innovative digital solutions to improve the energy efficiency of buildings. And the first presentation is on DigiBUILD project by José Hernández García. And José joined CARTIF in 2010, and he focuses on research and development in European projects. He holds a degree in telecommunications engineering and a master's in electronics and communications from the University of Valladolid in Spain. And his areas of expertise include digitalization, ICT for energy efficiency, data analytics, artificial intelligence, and decision-making systems. So, Jose, please tell us something more about the DigiBUILD project.
Hello, good morning, everyone, and thank you very much for the invitation. So, yeah, thank you for this kind of webinar where I will show something about the DigiBUILD project. So in this sense, my presentation will be mostly about district heating and cooling systems and how these systems and optimization can be used for the energy efficiency and digitalization, not only for buildings, but also taking into consideration the district as a whole, because at the end, we should not forget that a district is a combination of buildings that interact between them. So this is important point from our perspective about that district heating system, and how to use the digital twins for this for the optimization and the management of the systems within a Spanish use case that we are within this project. So let me start with why we need digital twins. Let me start with what is the definition taken from IBM. That is a virtual representation using real-time data, and that is useful for the simulation, use of machine learning, extracting value via reasoning, and make better decisions. So this is very important because at the end we have different definitions of digital twins and different levels of what is a digital twin. So we need to consider all these things together in order to know where we are, and this is the context that we are in DigiBUILD project. For us, this is the definition of the twin in this case. What is the very useful information that is provided by a digital twin? So first of all, we are able to simulate different conditions of the system, different parameters, different operative constraints, and we can simulate without the need of touching directly the network. So this means without having the problems with the comfort of the users. That is very important. At the end, we have the occupants and the users at home. So we can simulate and decide what is the best solution, or in other words, how to optimize the operation of the system based on the comfort constraints that the user has. Of course, visualize the current status of the network. If you remember the definition that I mentioned before, we are real-time data. This is very important because we can visualize in all the time what is the real-time status of the system, the real-time status of the buildings, demand side of buildings. So I took the comments from Anna about the fault and the diagnostics. So in this sense, in real time, how to know what is happening in the network if a fault or something is happening. Of course, at the end, we are in buildings. We have users, we have occupants with different patterns. So Anna also mentioned in the previous presentation about the different use of the energy for the comfort constraints. So we have different users with different feeling about the comfort, with different behavioral patterns. So this is, again, pivotal aspect. And we can use historical data to know about these behaviors and adapt the different resources in terms of energy for the different occupancy patterns that we have in the building. And last but not least, to predict what will be the needs in terms of energy for the next hours, for the next days, for the next months, and optimize the use of the resources that we have to buy biomass or this kind of resources. In this sense, let me go to the Spanish use case. So this is the set of buildings that we have in our district heating. It's composed of 20 buildings. Some of them are together. So you can see here this distribution of the buildings. This is it is located in the Valladolid city. That's the location where I live. Finally, this is Valladolid, located in Spain, continental climate. And in this sense, you can understand what is the context of where we are and why this district heating is important according to the climate conditions that we have in Spain. The configuration of the district heating is, as you can see in the slide, we have 3 boilers. First, 2 of them are biomass, and one of them is the gas-fired boiler to support the peaks of energy. The district heating network is providing energy to the 20 buildings I mentioned before, and also the electrical needs for energy that are coming from the grid, but also a PV system that uses power to heat in order to contribute to the domestic hot water demand. But also they are using for the buildings. But usually the excess of energy is not too much, to be honest, and is mostly used for the thermal energy usage. This is how the thermal is configured. So with the 20 buildings, the PV system is just in one of the most significant buildings in the district. That is the highest building in the system. We have 3 circuits with the different buildings, and you can see here that we have one substation or one heat exchanger per each one of the buildings. We have, as mentioned before, the 3 production nodes with the boiler room that is 3, 2 of them biomass and 1 of them gas fired. And as I mentioned before, the distribution system. And how we are applying this digital twin in our case. This is how we are working on. This is the schema of our digital twin. And basically, I am not going to enter into the details, but what I wanted to mention here is that we have the users' information that is very important, because not only for the feedback from the occupants about comfort, but also facility managers. So all the stakeholders should be involved in the digital twins. And in this sense, we have the comfort parameters from the users, but we have also the operational parameters from the facility managers, because they need to determine how the district heating network should operate according to the different set points for the temperatures, the different hours for schedules for the boilers operation, and so on. Usually, as I mentioned before, the different information, the real-time information is coming from the SCADAs for the system, so the real-time sensors that they have. But this is not enough in our case. We are using also what we mentioned, the district heating information model, that is contextual information that provides enriched data for us. That is like the configuration of the system, the pipes, the insulation of the pipes, the part of the buildings as well, how the buildings are insulated, and this information that provides us the demand and the losses of the system. That is very important. In many occasions, this information is not used in the district heating operation. This is part of the district heating, the buildings and the pipes and the distribution system. And of course, the production forecast. We need to know how many renewable energy we will have, the energy resources that we will have, but also the demand of the buildings. We need to know how the buildings will behave in the next hours according to the different climate conditions and the different operation and different comfort that the users needs. With this, we have created a model, a static model for the buildings, as you can see in the screen. So we based on CTGML information where you can see not only the buildings in order to provide the demand, but also the pipes of the system, the different circuits of the system, the first circuit, second and third circuit, in order to obtain the distribution losses in the network. And here you can see the 3D model of this system in order to provide the visualization that I mentioned in the first slide, that is also very important in the digital twins, how to visualize the information and to provide the useful data to the users. In this sense, you can see here how the digital twin looks like. We have the CTGML model with the different buildings in the area, and we can see some different information from the buildings. In this sense, some static information about the heated area, the energy demand, and so on. This will help the decision making. This is not the part of the static information is not changing along the time, but the energy demand is continuously calculated in order to determine which will be the energy demand in terms of domestic hot water heating and cooling for the mostly heating for each one of the buildings. And with this, we are able to simulate the different conditions of the system. You can see here the heat losses that we have and the pressure losses that we have in the distribution system according to the configuration from the user, and how the different circuits are being behave according to the operational parameters of the facility manager. With this, we are able to provide an algorithm in order to optimize the energy resources that we have that is currently being developed, but at least the user has this kind of information in the digital twin. That is, as I mentioned before, not only real-time data coming from the SCADAs and applying artificial intelligence, but also static information that provides us all this contextual data that is very important in the digital twin. According to these developments, or the benefits that we have in this design is, we, of course, with this data can define the optimal management and control strategy for the facility manager, how to optimize the behavior of the network that I mentioned in across all the presentation today. But very important, at the end, we are working with facility managers. They want to earn money, so we are reducing also the cost because we are reducing the waste energy in the district heating. We are not generating more energy than needed. But also we're enlarging the life cycle of the boilers. So we are able to balance the load for the different boilers in order to provide just the demand that we need, so not providing more energy than needed. And this means that the boilers will work less hours than currently, so improving the quality of life of these boilers. Monitoring of the system. So in the first slide, I mentioned real-time monitoring. So we're all the time monitoring the systems and adapting the set points and the different conditions of the operation according to this data. And yeah, that's all from my side. Thank you very much for your attention. And of course, I'm here to hear from you.
Thank you very much, Jose. Thank you for this very interesting presentation. And it's great to hear that you are using digital twins at your project demo site in Spain, which allows you to continuously monitor the system. And thanks to this, you are actually able to forecast demand and renewable production in order to optimize the resources. So thank you. And we will now continue with the next presentation about the artificial intelligence tools being developed within the Build On project. And therefore, I would like to welcome here Sofia Mulero, the coordinator of the Build On project. And Sofia holds a master's degree in telecommunications engineering in big data science, and her research interests lie in the field of energy efficiency with a particular focus on the ICT sector and the application of data science and artificial intelligence in the field of energy. So Sofia, what kind of digital solutions are you working on within the DigiBUILD project?
I will try to give an overview of our digital solutions. We are trying to provide an open solution that can be applied in different kind of buildings. We are also working in the digital domain, trying to go a step further, also to provide control capabilities, and actually that's one of the main challenges of our project. Well, first of all, I want to thank you for the invitation, for this opportunity for Build On. I will continue with my presentation.
Sofia, I'm sorry to disturb you, but I think that the sound is not very clear. Could you please perhaps come a little bit closer to the microphone or I know that you are
Yes.
in the same room in Jose, so perhaps just, yeah,
Yes.
unmute
So,
yourself. And
yeah, I hope. Okay. So I will start giving this presentation about artificial intelligence competencies in building performance. Just to start, brief overview of the project. Build On is a Horizon Europe project which started last year in May and will finish by October 2026. It's a 6 million, around 6 million euros project coordinated by CARTIF, and we are 20 partners coming from 9 different countries. The main, well, the project states for smarter, was funded under the goal smarter buildings for better energy performance, and the main goal is to build the next generation of smart buildings. That's why I was mentioning before, we try to provide this replicable generic solution to facilitate the communication between the different systems, technologies that can be found around the building, in order to be able to replicate and provide straightforward solutions in different kinds of buildings. Beacon is built on three main pillars, have these three main dimensions: business, social, and technical. And we will delve more into the details of the technical one. Today, there are three main components that are delivered in the framework of the project. The first one is this interoperable framework to facilitate this seamless exchange of information. Secondly, we have a set of smart energy management solutions through the map of services. Later, we will provide more details about this. And finally, the digital tools for building performance simulation and also for operation. As I was saying before, this is actually one of the main challenges of the project because we will try to go this step further. Okay, if we go more into the details of the map of services, the map of services correspond to the monitoring, assessment, prediction, and optimization services. These categories are divided into different layers. There's one layer, more analytic, in which we are going to provide services first for energy assets monitoring and benchmarking, and secondly for energy fingerprinting. While in the case of the second layer, which is built on top of this one, will be orchestrated together. We will provide this automation and control services in three main pillars for user comfort, decision strategies, assets control in the building, and also in the domain. The build-on solution will be demonstrated in 5 pilots, but together we will focus on 2 of them, which are residential. One is located in Spain, the other one is located in Finland, and we are covering different typologies under different climate conditions, energy configurations, having different kind of stakeholders. These 2 buildings have quite a lot of similarities because of the typology, also the kind of stakeholders we can find, but there are some differences between them, as we will see now. In the case of the Helsinki pilot, it's a building, a 4 floors building with 32 apartments, which was built in the 70s and renovated in 2022. The main goal here is to enhance this building performance of the whole building while we keep the environmental conditions for the residents. We can see here a more detailed description of the energy systems that are available in the building on the left of the slide. There's a hybrid heating system with a one source heat pump, and the building is also connected to a district heating network. We will try to reduce the use of the gas powered by the district heating network, but the heat pump is the main source. There's also a mechanical centralized ventilation system with the heat recovery unit. And in the framework of the project, we are installing electronic radiator thermostats per room in all the apartments and also in common zones. Also, these thermostats are complemented with different kind of sensoring for temperature, humidity, and CO2 levels. So this way, we will try to provide these cross-domain energy assets control services to enhance the energy efficiency of the building, considering the energy generation patterns, consumption, also the user's feedback, and we will try to provide VR control to users. As I said before, this control will be done at the room level, and we will also have digital twins to support the energy performance simulation. In terms of SRI, we will try to SRI, the smart willingness indicator, we will try to tackle the heating ventilation domains in this heating and cooling domain. There are a set of actors, stakeholders that will benefit from the solutions, from facility managers to the district owner, to the providers, and for sure the building owners and users. And we are applying from the map services, all these kind of services from the analytical domain, and this rest and height generation and distribution service. If we jump now to the Valladolid pilot, which is located in Spain, the pilot is quite similar to the previous one, but there are some differences. We have, in this case, we are focusing on this tower building that was presented before by José. This is part of the district heating network he was mentioning before. The building has 14 floors, 56 dwellings, was built in the 60s, renovated in 2018. And the goal here will be to improve this energy performance without compromising the indoor environmental quality of the dwelling, and also considering that there are some technical constraints in the building and also some constraints related to investment. As this building was renovated some years ago, there's not much room to make this huge investment. That's why we are proposing a digital solution which is much more affordable. In the left, we can see the technical, the systems infrastructure in the building. In this case, the building is connected to this district heating network, but there are 20 substations. This is represented by one of them. There are 2 biomass boilers and 1 gas-fired boiler, and a thermal storage tank for domestic hot water, another to be ventilated facade, and actually this energy was mainly used for the domestic hot water. We are also installing here thermostatic valves. We are making them smart, and temperature and heating sensors. So we want to prioritize the use of the renewable energy sources to reduce the carbon footprint of these high emission energy sources, and to provide these energy assets and device control capabilities to improve the energy efficiency, the use of renewables, and also to integrate the user's feedback. In this case, we are providing not only digital twins for performance simulation, but also to be able to control directly the technical energy systems of the building. Mainly in terms of the SRI domain, we are improving the heating and the domestic hot water domain. And here we can see that the stakeholders that will be benefited from these solutions are quite similar to the ones that were presented in the other file. And just to conclude, I wanted to highlight some of the challenges that we are trying to face in the framework of the project. The first one is this lack of awareness on the potential of these smart building technologies. Actually, end users are not very familiar with these kind of solutions. This is a real barrier that we need to face in order to demonstrate all our technologies and the impact that they can have. Secondly, that artificial intelligence, which is the basis for our services, can never replace end users. And in this case, we are moving from the recommendation level to the control level. So the risks that we need to face are even more. Yeah, and we need to keep users in the loop and consider all the feedback they can give us in order to make better decisions. Finally, that the lack of replicable solutions in the market is a fact. That's why we are going to provide this generic solution. In this case, we are demonstrating the same solution in different kind of buildings with different configurations of services, hoping that we can break this barrier and enhance this smartness activator of buildings at the scale. And that's the end of my presentation. Thank you for your time.
Thank you very much, Sofia. And yeah, indeed, we are in the era of artificial intelligence technologies, and it's crucial to focus on finding the best ways how to use them. And I think that the Builden project is particularly interesting because it goes a bit beyond simply providing recommendations for optimizing energy operations, but it actually aims to implement control mechanisms, which allows us to improve the energy performance of buildings while still maintaining the thermal comfort for the occupants. So many thanks for sharing these insights, Sofia. And as we are today discussing smart tools and smart services for buildings, it is also important to be aware of the new EU scheme for assessing the smart readiness of buildings. And therefore, we are very happy to have here with us the coordinator of the SRI Enact project, Stamatia Rizu. She is the Research and Development Manager at Singular Logic, leading the research team in data technologies and artificial intelligence applications. And Stamatia holds a diploma in electrical and computer engineering from the National Technical University of Athens and a PhD in distributed systems from the University of Stuttgart. And with over 10 years of experience in European research and development projects, she is currently coordinating several EU-funded initiatives aimed at developing ICT solutions for energy efficiency in buildings. So Stamatia, or Martina, as we normally call you, could you please explain what is the Smart Readiness Indicator and what are the tools that are being developed within the SRI Enact project?
Many thanks, Laura, for this opportunity to have this presentation with all the esteemed presenters. So as you anticipated, we will shed some light on the new scheme about Smart Readiness Indicator, and we will present some ongoing work in the context of the LIFE project, SRI Enact project that I have the honor to coordinate. Let me go a little bit to give some background of for this presentation. Maybe already the audience, and I saw also in other presentations there were some references about SRI, but very briefly to say that the Smart Readiness Indicator is a new EU scheme instrument that aims to rate the smart readiness of a building in terms of its capacity to perform in three main key functionalities. The one is related to optimization of energy efficiency. The second one is to the ability of the building to adapt to its operations to the needs of the occupant, and the ability to adapt to signals from the grid, the so-called energy flexibility. very briefly, we will not go into much detail to exhaustively present the whole scheme, but just to give an overall idea, the scheme is basically includes different 57 different smart ready services, as we'll call, and the services are grouped into 9 technical domains. As you see, heating and cooling is one of these domains that is also part of the focus of the discussion today, and there are also other parts related to domestic hot water, ventilation, lighting, the dynamic built-in envelope, electricity monitoring and control, and electric vehicle charging. Just to give also a little bit background on the SRI and how evolved over the last years. It started back in 2017 with the definition of this new indicator and the first technical study, and together with initial stakeholder consultation. In 2018, it was included as an optional scheme in the revised EPPT. Then it followed another technical study with which proposed a concrete calculation for the SRI scheme. And in 2020, we had the release of the formal definition and the calculation methodology upon which our project and other sister projects are also relying to calculate the SRI score for the buildings. In 2021, it was composed the SRI support team. We do not have, I mean, we are right now 2024. After this, actually, new project, especially live projects, SRI Enact, and 3 other sister projects started that had a specific focus on the implementation of tools and methodologies for the SRI. So the landscape is continuously evolving, and we try to also follow all these new developments that are happening from the different initiatives. Coming more on our positioning as a project in SRI Enact, we started back in December 2022. The duration of the project is 30 months, and a main goal of the project was to test really the SRI scheme in 8 different countries across EU. You see here the different countries, including Greece, that together with the National Technical University of Athens and another sister company, we are collaborating together in the pilot scheme in Greece. But we have partners all over Europe. I will not exhaustively introduce, but overall we cover, as you see in the map, a quite large part of heterogeneous profiles, let's say, for different countries. The goal of the project itself has been to basically has the goal is divided in 4 main pillars. One pillar is about the stakeholder engagement. This is a transversal goal for our project. We want to continuously work with stakeholders, and since, as I said in the beginning, SRI is a very a dynamic scheme. Right now, we want to be in contact with the national stakeholders to see how we can practically find implementation pathways for SRI in the different countries. Secondly, we're also developing, and as I will say later, we have already released a toolkit for facilitating the calculation of the SRI, and also providing some additional decision support tool that could help in proposing potential smartness upgrades of the building. Another main goal of the project has been actually the pilot assessment. So we have a goal to apply SRI and calculate the SRI for more than 1,000 buildings across these 8 EU pilot countries, and to do so we will train at least 120 SRI auditors that will help with this ambitious work that we have set. And finally, as part of the final outcome of the project, during the final months, we want to explore and develop concepts for the financing of the smartness upgrades, which I think it's a very important challenge that is relevant for all these different projects. The achievements so far, as I said, we have started almost 1.5 years ago. We have started right away with the stakeholder engagement. We have established 8 national stakeholder liaison groups across the pilot countries. We have released the SRI NAC toolkit. This was an incremental release. We released the assessment tool, then the decision support tool, and these digital tools are continuously refined and supported by the technical partners in order to address all concerns that we receive from the support line. In parallel, we have started with the training of the SRI auditors. We have up to now trained more than 50 SRI auditors. We have delivered several training webinars. And as part of the first pilot cycle, that it was a small scale pilot, we have done more than 20 SRI assessments. This figure is continuously raising, and we now enter the phase that we will really scale up, because the first phase was mainly to test the tools and refine the whole methodology before the actual scale up of the project. So very quickly, in terms of the stakeholder engagement, as we said, we have created these liaison groups. We ran at the beginning of the project 8 national co-creation workshops that were very informative and instrumental to raise awareness across the national stakeholders, and we worked also in parallel with all relevant initiatives at national level to try to maximize the impact of our work. This stakeholder engagement is a continuous transversal activity that we will follow up across the project in order to provide also some meaningful policy recommendations towards the end of the project. In terms of the tools, as I said, we have now delivered the toolkit, which is available in this URL, and actually we have this includes the assessment tool and also the decision support tool. The toolkit offers different user roles: the role of the assessor, the role of countries in the EU supervisor and administrator, that provides also some statistics upon the assessments of the tool. In terms of the training, we have delivered a comprehensive training program. We started with an internal auditors training. We fine-tuned this training program, and we recently delivered the training program that actually leads to a certificate of completion for the completion of the training activities. And we have currently certified more than 40 external auditors. This is ongoing work, and we will continue with more webinars and activities. In terms of the SRI assessments, I will only focus for the first cycle that finished in April 2024. But as I said, this figure is continuously raising. On the base of 21 assessments of buildings, we have an average score of 27. In general, as you may say, it is not easy to receive a very high SRI score. There are different services and different functionality levels, and achieving a very high score is quite challenging. We will analyze all these different cases, make statistics for the different countries. This is a preliminary work. I would only give us an example, a summary of some pre-pilot tests that ran in Bulgaria with 4 different buildings. You see different types of buildings: office, theater, hospital, kindergarten. They have an energy class B. But SRI score vary from F to D for the first building. There are several reasons behind this score. We have put together some main reasons here that for the office building they had higher number of applied smart technologies. This particular office building that achieved a high score had constructed to meet the requirements of the BREEAM standards, and they had a PV system installed, and in the car park they have also EV charging points. So there are different aspects that affect the score. The average SRI score for these 4 buildings in Bulgaria is 36, but as I said, we will continue with more assessments, and I think that at the end we'll have much more interesting insights about the application in different heterogeneous building and conclusions that we can get in the different countries. So our next steps in the outlook is basically scaling up the work that we have done up to now, go on with more trainings, with more assessments, continue with the training seminars, recruit external auditors, extract overall lessons learned and blueprints, and of course promote actively the results of the project. And I take the opportunity to kindly invite you, if you are interested to make an SRI assessment or you are interested in the project, we will be happy to get in contact. Also Laura, as our dissemination manager, and myself, and we are always very motivated to have collaborations with other projects in the context of the SRI scheme. Many thanks.
Yeah, thank you very much, Martina, for sharing this valuable information. And I believe that it's very important to understand the smart readiness indicator, because the SRI scheme will soon become mandatory for some types of buildings. And it's great to hear that thanks to projects like SRI and ACT, there are already tools available to help us not only to calculate the smart readiness indicator, but also to estimate the impact and financial cost of proposed measures to increase the SRI score over building. So many thanks. And having learned what is currently being developed in terms of digital tools to support energy efficient buildings, let's look at the actual definition of an efficient building according to the Fit for 55 package. So it is my pleasure to welcome Remy Colombet. Remy leads the policy work of Efficient Buildings Europe in Brussels, and in recent years he has focused on the revision of the Energy Efficiency Directive and the Energy Performance of Buildings Directive. And prior to joining Euroace, he spent 5 years in the renewable energy sector at Ocean Energy Europe and worked on local transition plans at energy cities. So Remy, please, the floor is yours.
Many thanks for the invitation. Very happy to address you today on this topic. So my presentation will broaden a bit the perspective and look back at the past few months during which several key pieces of legislation were agreed at European level and will define how buildings will be shaped in the coming years. Just for those who don't know us, Efficient Buildings Europe, were formerly called Euroace. We're a trade association based in Brussels, and we have the specificity of covering all the solutions that are necessary to make buildings more efficient. So we look both at passive elements, the envelope, windows, but also at all the active heating, cooling elements, the control systems. So we're bringing this kind of holistic perspective to building efficiency, and it's what I'll try to convey here, and how to make sure that we improve both in a coordinated manner. So we've looked a bit at what's in the 5555 package, and we're soon going to re-release actually this infographic that we made, looking at all the provisions in the different file and see how they align, what they cover, what is in there basically for buildings, both from decarbonization perspective, but also demand reduction perspective. So these are really the core objective of the package, where we see that decarbonization is a key one, reducing greenhouse gases emissions for climate change mitigation, where we have provisions in the Energy Efficiency Directive, in the PBD, but also in the Renewable Energy Directive and the carbon markets that are now including buildings. Next to that is another core objective, is reducing energy consumption. This is a way to decarbonize, but also to lower bills for consumers, increase overall competitiveness of the EU economy, as the more you lower the demand for individual buildings, the lower the demand for the whole system, the lower the prices. And this is key in turn to eliminate energy poverty on the long run, which is a core social objective of the EU. I'd add to that provisions on flexibility that we see more and more, where efficient buildings in the medium run will be buildings that are with very low or no energy demand at all, decarbonized heating cooling systems, and flexible, able to respond to signals from the energy system. Now, there's a big question now that we have all this shiny, ambitious targets, is how do we plan and how do we make sure that there's logical steps towards the achievement of this fully decarbonized building stock. We have different provisions in different files that are not really aligned at the moment, and this is a potential challenge for member states in the coming years. You have the Energy Efficiency Directive, where you now have mandatory heating cooling plans for larger cities, with a focus on increasing energy efficiency, preparing for low temperature, also provisions on the decarbonization of district heating and cooling. And next to that, you have provisions on other files regarding building energy renovations, namely in the national building renovation plans, the minimum energy performance standards. So sort of not calling them that directly, but renovation obligations, phase out of fossil fuels in buildings, and mandatory ramp up of the share of renewable energy in buildings in the Renewable Energy Directive. Now, just to focus a bit on a few of these measures that I just mentioned, regarding the timing, you'll have the end of subsidies for standalone fossil fuel boilers already from the 1st of January next year onwards. The directive, the EPBD, sets legal basis for member states that want to go further and ban fossil fuel equipment. This will be a key incentives for consumers and businesses to switch to cleaner, fully decarbonized solutions. And there's a 2040 requirements there. It's not very well been understood at the time of the presentation of the agreement, because some thought it was a full ban on and a full phase out of boilers and fossil fuel appliances. It's actually a requirement for member states to put in place legislation in view of phasing out fossil fuels by 2040. So not clearly directly binding provision, as in a hard ban, but member states will have to show that they're taking the steps to fully decarbonize their heating and cooling sectors. This will be next to the minimum energy performance standards. So the renovation obligations that I mentioned, they're very stringent for the non-residential sector. So we'll have to renovate the first 16, then 26% worst performing buildings in the sector. That's where you get the most efficiency gains, and they're very stringent obligations. So member states are already looking at how to implement those measures. Timeline are 2030 for the first batch, 2033 for the second one. And next to that, you have a very different approach that was chosen for the residential building stock, where there's no ability to find an agreement, especially within the councils or the member states, on having something very stringent and binding for the residential sector. So an average trajectory approach in terms of primary energy consumption was chosen, where you have minus 16% by 2030 and minus 20 to 22% in 2035. So regarding the achievement of these targets, it's a bit more open, it's leaving a bit more flexibility regarding how you want to achieve that. So as it's primary energy, you can either look at decarbonization of heating and cooling or lowering the overall consumption through energy renovations. Now, having said that, what now? How do we really achieve that? How do we make that match? So one of the main opportunities to coordinate and actually go from sort of ad hoc separate policies to something a bit more integrated, looking at real industrial policy for the sector, would be the national building renovation plans. This is an exercise where member states have to translate the targets that have been set at the European level into concrete policy measures and put next to that the appropriate funding, the appropriate requirements at national level. And this is real time where stakeholders, all of us, we need to be engaged to make sure that this is coherent and there's a long-term stable framework for the sector where there's clear indication for citizens and businesses of when do I need to install my building, when do I need to change my heating system, is my city does my city have plans for deployment of or the extension of district heating and cooling system, when it can plug to that. So this really needs to be answering all the various questions that actors might have, provide clear information, so that also on the company side, the industry, there can be planning in terms of the skills people that hired, the extension of production facilities that are there in Europe to meet the demands of the sector and actually achieve the targets that have been set by the various pieces of legislation. Minimum energy performance standards are also very interesting because they're meant to address the worst performing buildings. And those might be located in the same areas. There's an opportunity to coordinate and look at full district energy renovation combined with the decarbonization. And so make it a bit more efficient, go at it in one go, benefit from economies of scales, and make it a bit smoother for occupants and businesses in this area. Finally, information is really key. And we see that there are provisions in this text to indicate to, again, consumers and businesses whether their building will be fit for the next generation of technologies that will arrive. So in the energy performance certificates, for example, there is a provision to indicate whether it's fit for low temperature. This is key, and this is kind of a link between the passive and active elements in efficient buildings. But for that, we'll need to work all together on the enabling conditions. So those are the building blocks, the levers that need to be activated for the works to actually begin and ramp up if we're to meet our climate and energy objectives. The first one is clearly financial support. And there we see that obviously the private sector, the public sector, sorry, needs to play a key role, especially for the most vulnerable consumers, where there needs to be clear subsidies, potentially grants for the ones that cannot afford those energy renovation, the switch. But in the design of the subsidies, there can be a link between energy renovations and decarbonization, making sure that they're addressed in a logical order, that there's combined funding that makes citizens and business able to address both. Next to that, obviously, public funding will remain a very small share of what's necessary to reach the levels that we need to reach. And new financial tools to unlock private finance will be needed in the coming years to address both the decarbonization of heating, cooling, and the performance of buildings. Information is also key. Who do I need to talk to? Who are contractors that I can trust? And there, the development of one-stop shops will be really key. Their provisions both in the Energy Efficiency Directive and in the PBD, with a requirement for member states to deploy one-stop shop per 80,000 inhabitants, or one per region. This will be key prescriptors of information for the works, but also potentially the hubs where all the various improvements, innovations that have been developed and that we heard about today will be able to be applied directly to building renovations. And finally, innovation will be key. We often hear the construction and renovation sector being described as something very slow, not very innovative, a bit set in its ways. But if you look at it, and especially over the past few years, there have been a strand of innovations that have that are actually very interesting and will lead to significant progress in the sector. Here are a few. I won't come back too much on the right side of the slide because it's been addressed very well by the previous presenters, but we clearly see that there's no time to waste. And some member states have pushed back saying, well, we can't act because we don't have the data. But we see very interesting solutions in terms of proxies, tools based on machine learning to identify worst performing buildings. Banks are already using some of the tools with very high accuracy, where you input the basic characteristics of your buildings, you have construction and works that have already been done to the building, and you get a fairly accurate picture regarding where the worst performing buildings are and the work that you need to be doing to improve their performance. Digital twins, we mentioned that, they're essential to design better buildings. And so looking at 2030, when we need to have zero emission buildings, this is a key tool to have in our bag to really design from the start buildings that are most efficient. But as we've seen, operating and leading the work and managing renovations will be key there, and digital buildings have a key role to play in facilitating those operations. Spain has a very good roadmap to bring digital twins and building information modeling into the game of building and renovations for very large projects first. But this is a very good first step that other countries could take inspiration from. We also have planning tools to assess financing and even materials and products needed. We've seen really good projects in the Basque Country, for example, where researchers have been looking at a whole neighborhood and really assessing step by step the projects for energy renovations and decarbonization, looking at the finance needed, looking at the materials needed. And this is really the kind of planning tools that we would want to see spread throughout Europe to help and improve policy making, making it a bit clearer and long term. One of the main issues and challenges for our sector, both for energy renovations and decarbonization, has really been the fluctuation and instability in terms of support programs, goals, requirements, where we see that it's changing from a year to another, and it's preventing actors from really engaging in these projects that are sometimes a bit long, where you have to align the planners between getting the right amount of money, the contractors, the permits. And so having a stable framework will be key really to deliver on those points. Now, just to finish on the innovations that we have, especially for district heating and cooling, we see that predictive maintenance, software to improve demand response are really key to make the whole sector more efficient, more appealing, and cheaper in the end for users. And we see that as very positive developments. So this was it for me. Happy to take any questions on legislation for efficient buildings.
Thank you very much for your presentation, Remy. So yeah, it seems that achieving DHC buildings is essential to meet the ambitious goals of Fit for 55 package. And by decarbonizing the building stock and improving energy efficiency, we can really ensure a sustainable future. And the focus should be really on innovation, digitalization, and coordinated efforts across the sector. So once again, many thanks to all the speakers for your very interesting presentations. And as I promised at the beginning, we will have some time for a panel discussion. However, we are a bit behind the time, so I will kindly ask you to keep your answers very short. And I will start directly with you, Remy, as you just finished your presentation, because based on the comprehensive strategies outlined in your presentation, we see many new measures being introduced to fully decarbonize buildings by 2050. For example, the phasing out of fossil fuel heating by 2040 through the national building renovation plans. Could you tell us which of these measures do you think will make the biggest difference and which will be the most challenging, in your opinion?
I think the answer is the same for both questions. It'll be the planning tools, NBRP, so National Building Renovation Plans, and local heating maps. This is clearly the tools where it can allow the various ministries to talk to each other and design a concrete, stable framework for the future. This will be a challenge, and I think a role for us to play in the coming months to make sure that these discussions actually happen. There's input from the whole stakeholder community, and that we're on the right track to decarbonize our building sector.
All right, thank you very much for your answer. Now, my next question is for you, Anna, because you mentioned that energy consumption in buildings is influenced by both building characteristics and human behavior. But how can we adopt a holistic approach to energy efficiency that effectively addresses both aspects rather than focusing only on physical home repairs?
I would say that actually this influx of data from the building sector could be a nice and easy way to actually include both the building characteristics and the occupants, because those meters, for example, they exactly account for what is the house, both the house and the occupants inside. So the real data we have from the building sector is actually, I think, the key to account for the combination of the building and the occupants, because we know also that the same family living in a different house, if we move from the old to the new house, then they will also change their heating habits, because they will be surrounded by new materials, by new systems, and then they will also change and adapt. So we cannot just expect that it will be the same family, but just living in the new house. So I see that probably this digitalization will help us to account for occupants, at the same time not interfere with their privacy, because I think this is often a challenge that occupants, they don't want to be disturbed in their private lives. So when we speak about the residential households.
Yes, definitely. Thank you very much. Jose, I have another question for you, because you talked about the digital twins as a solution you are working on within the DigiBUILD project. But could you please tell us how either facility managers or inhabitants of buildings take advantage of the digital twins, and how can the end users basically benefit from this solution?
Yeah, okay. Thank you for the question. Yeah, indeed. First of all, I will start with the end users. So end users can provide their comfort parameters. So at the end, they will feel more comfortable at home with the less use of energy, and then this will be something related to the bill, the energy bill. So they will be less for the energy, because they are using less energy for the same comfort. This is for the end users, but also for the occupants, let's say. But for the facility managers, this part is also related to the cost, because they will use the optimal resources for the energy. So like an ESCO, one ESCO can save energy and can save cost because of this energy, and also to increase the life cycle of the boiler. So in this sense, they have not only the comfort and operational benefits, depending on the profile of the stakeholder, but also the cost and the economic benefit that they will have in the energy bill, but also in the energy resources to be used.
Great, thank you very much for your answer. My next question is for Sofia, because through your presentation, we learned about smart services you are developing within the BuildOn project. Could you perhaps tell what are the main challenges in implementing these smart services in the BuildOn buildings?
Yes. Well, as I was saying during my presentation, there are like three main challenges. The first one is interoperability. So to be able to access to the data and also to access to the technical building systems is not easy. This needs to be solved as a first stage. And for this, we are proposing a generic solution trying to abstract all this complexity at the field level. This way, it's easy to apply solutions on top of this. So the map of services that we are proposing, the analytical part is quite easy, quite straightforward to implement, while to interact, to make the interaction, to orchestrate them with the kind of solutions such as the one for optimization, it's a bit more challenging. Moreover, if we try to implement this in an automatic way, considering also user feedback, trying to keep the comfort conditions in a good level for users, this is not easy. So that's one of the main challenges we try to face, to have the compromise between the automatic control while considering that artificial intelligence cannot make the final decision.
Great, many thanks, Sofia. And I would like to come back to the smart readiness indicator. So, Stamatia, you explained that there are 9 technical domains that are taken into account when calculating the smart readiness indicator, including heating and cooling. But as during this webinar, we focus more on the connection between efficient buildings and district heating and cooling systems. Could you please tell, have the DHC systems been included in the existing SRI methodology so that they can be emphasized where needed?
Thanks, Laura. Indeed, as you mentioned, there are 2 domains, heating and cooling, and under heating there is a specific smart service related to control heat production system that is also very relevant to district heating. This particular service provides different functionality levels, going from control heat production facilities up to variable temperature control depending on the load. So it all depends, the SRI score at the end depends on the functionality level for this smart service, which is also related to district heating. Of course, district heating provides also flexibility and an additional flexibility, which is also relevant, but the exact impact to the SRI score, it all depends on the functionality level that each building is achieves.
Right, thank you very much also for your answer. All right, so I don't see any additional questions in the Q&A section. And therefore, as we approach the end of the webinar, I would like to just briefly conclude that the insights we have heard today underline the close link between energy efficiency in buildings and district heating with the critical role of digitalization. And Euroheat Power is committed to driving the transition of the district energy sector with a strong emphasis on 2 critical areas, as our project portfolio is currently one of the largest among energy associations, with a strong focus on digitalization and buildings, as in the projects presented today. So if you want to stay in touch with news from the sector, I kindly invite you to follow us on social media channels. So once again, many thanks to all the speakers for your very insightful presentations, as well as to our participants for attending the webinar. I really hope that you enjoyed it and that you found the information useful. So I wish you a wonderful day and goodbye.
Thank you all.